All right, we are going to start our next unit, Unit 7. And so let's recall where we're coming from. We have just been recently computing our probabilities with our normal model. And that is huge. That's a big, big deal. But we've kind of been hiding something from you. And we've been making a huge assumption. And that is that we've just gone about life saying, hey, everything is normally distributed. Let's do z-scores and normal model math. Well, that's a big deal that we just kind of skated over that assumption. How do we know that the shape of a distribution is approximately normal? How do we know, um, that what the population set of data looks like? It could look something like these pictures down here. Here's actually one that I got from the U.S. population distribution of 2007, and these were the ages and the proportion of baby boomers, 12 to 62 years old. Anyway, or 42 to 62 years old in 2007. So obviously not normally distributed. So all of our statistical inferences and our analysis hinge on being able to compute with normal model math. Therefore, we must be able to accomplish something and figure out what is the shape of the distribution. So here we go. More often than not, we do not know it, or we don't know the whole population. With proportion problems, there's not even a population because that's categorical. Is the M&Ms blue or not M&M or not blue? What shape is that? How does that data get collected? So, therefore, it is imperative that we discuss this important statistical component called sampling distribution. So that's our next big idea. A sampling distribution is the collection of and how they get shaped out a distribution of samples, a collection of a bunch of samples. So we're going to deal with two different kinds, a proportion sample. So we would take from the population, we'd look at all these things, and we're going to deal with M&Ms. So if we had a whole bunch of M&Ms, we would look, okay, what's the proportion of blue M&Ms that you got? And what's the proportion of blue M&Ms your friend got? And what's the proportion of blue M&Ms your teacher got? And then we would plot those, and we're going to see what the shape of those samples comes out to be. So right now, hopefully you get the idea they're probably going to come out to be approximately normally distributed, but we're going to put this into action and see what happens with our real world data. So here we go. Then later in this unit, the second half of this unit will be based on doing it with means. So like the average time that people take to run a mile or whatever. And so here we would have maybe what it would look like if you have people who are exercisers who normally are fit, and these are the people who are not. So see, maybe the population is bimodal, but if we take samples of a certain size, then it comes out to be this shape, approximately normal, where we can do normal model math. Okay, so enough about that. Let's now get into it. We're going to see that as we're going to take one single sample, and this is going to be your P with a little hat on top, your P hat. This is your P hat, and you're going to use it to estimate the population P. And we're going to be doing this for M&Ms, for blue M&Ms. Now, can you be sure, do you think that just you getting one little sticker that's a P hat is going to be a good representation for the population amount? Well, hopefully you say no to that, because I doubt one sample is going to be like the population. You could be, one of these little samples way over here. The idea is, as we take many, many samples, then they will start to center around the true population amount. So if the M&M's company says 24% of the M&Ms are blue, then some people will get lower p hats. Some people will get higher p hats. And this is sampling variability because you get different data than me because of sampling variability. But in the long run, over many, many samples, we see a predictable pattern that is centered around the true mean, the true average location of those samples. So, in theory, here's what we know. The average of the p hats should be where the population proportion is. So, for example, in 2008, the M&M's Candy Company put out the distribution of their M&Ms from Hackettstown, New Jersey, and those were 24% blue. And then the orange was 20%, and you can see the other distributions here. But, and this happened for real, I did one of these sampling distributions. It looked like this, and I expected the data to be centered right here. Here is the 24%, but the data looked like this. I actually think it was even worse off than that. I mean, it was something ridiculous. Like, here's this where the 24% was centered, and my data looked like this. And I was like, what the heck is happening here? I was crazy perplexed and wondering, why is this data centered or so far off from where it's supposed to be centered? Well, so I called up the M&M's company and I said, hey, what is up with this? Why are your proportions all messed up and way different than what they're supposed to be? And they said to me, well, read the label on the back of your M&Ms. Where did they come from? And I said, I don't know, Hackettstown, New Jersey. And they said, no, look, because we have opened up a new factory this year. It is in Cleveland, Tennessee. And so if your M&Ms came from Cleveland, Tennessee, then they may not be 24% blue. They could be 20% blue. Mind blown. So whenever I looked at my M&Ms, sure enough, they came from Cleveland, Tennessee. And so the fact that I had all of my samples located and centered around somewhere different than where I thought they were going to be was happening because the true center was at the 20% mark. So we are going to we're going to get M&Ms. In fact, I went and picked these up at the store. I'm going to see if I can see where these are from. Haha, I can tell where they're from, but I'm not going to tell you. So we're going to take a whole bunch of samples. In fact, that's what the bottom of this thing says. We want to figure out, where are our M&Ms from? Are they from the New Jersey factory or are they from the Tennessee factory? And so how do you think we can do this? We're going to take many samples and see where those samples are centered. Okay, so that sets up the lab. You are then going to get a little cup of 50 M&Ms, okay? And you're going to count your M&Ms and make sure you have 50 because all of our samples have to be the same size. So you're going to count out 50, no bias. So you just fill out 50 so you're not subconsciously looking for more than of the blue M&Ms, okay? And then you're going to count how many of yours are blue, and you're going to do that number of blue out of 50. So your P hat is going to be your proportion of blue M&Ms in your sample of 50. And then you're going to go, or I'm actually just going to probably collect your number, and let me move this out of the way because we don't know where our data is going to be. So see, each one of these little stickers represents my students in the past who had a sample. And so we're going to place all of those on this chart, and we're going to then see what it looks like. So we can decide, does it look to be, this is a separate past year, does it look to be centered at 24%? or does it look to be centered at 20%? So obviously this one came from Tennessee. All right, so that's the end of this little video. It sets it up. Let's collect our data and see what happens. All right, I will see you after we collect our data.